Hello and welcome back. Enrichment again today. Series is the topic and one of my favorites, of course, and we're trying to sum this infinite series there, which looks like it has a clear pattern. I hope we can see the pattern, the obvious pattern. 1 times 2 with 3 factorial. Factorials going up in ones, starting with 3, then 1, 2, 3, 4, 5, and 2, 4, 2, 4, 8, 16, 32. These are powers of 2. And we're trying to sum it. Okay, 5-star question. Pause the video and have a go at it. It does require further maths, a little bit obviously knowledge of some power series from further maths. But other than that, it just requires ingenuity. Okay, a little bit about this particular question. It's not one of mine in terms of I haven't actually personally written, although it belongs to my collection and it's been with me for a very long time. I have forgotten its origin. I really do not remember where I got this particular question from. Okay, what's the first thing we should do for something like this? Whenever you have a series, probably if you have it in explicit form or if you have it in sigma notation, write it the other way around. Sometimes one form can allow you to see things that the other form doesn't allow you to see. So what I'm going to do, I'm going to write this in sigma notation somewhere here. So this is the sum. And I'm going to move out of the way. And this let's run it from 1. It doesn't really matter. From r is equal to 1 to infinity. And we have factorials at the bottom. In order to match the 3 factorial, we're going to need to put r plus 2 if we're running it from 1. And this is going to be, of course, 1, 2, 3, and so on. So that's an r. That's for the leading number on its term. And of course, we got a power. And the power is 2 to the 1, 2 to the 2. So it's 2 to the r. So this is what we're trying to actually sum. So that's exactly the same as that. Any clues now from either form? This particular one does not really give me any information that I can kind of see. I can see the pattern. This one is a little bit better because I can see a couple of things in there. I don't know what you see, but I certainly see, first of all, the factorial term. Let me just write the exponential function. As an example, e to the x is, of course, a well-known power series. We can run it from r is equal to 0 to infinity, x to the r over r factorial. So when I'm looking at this term, perhaps it might have something to do, I don't know yet, with the exponential function. If you look at this bit here, 2 to the r over r factorial is the exponential. It will probably be something like an e squared. Of course, I'm not putting the sums in there, it's all the rest in there. But I have obviously the factorial having the wrong quantity. Is not r factorial, it's r plus 2. So there's some kind of shifting. Of course, I don't have this r there. How can I somehow get an r in there? One way is perhaps to multiply by r. But then you got to think, how am I going to put an r inside the sigma? That's not easy. I don't even know if it's possible. What else? How on earth I can get this r from there? I can get it from differentiation. You see, if I differentiate this quantity, let's go and put an x in there, because the r is equal to, sorry, the x is equal to 2. I'll probably put it at the very last stage. But suppose I had an x to the r in there, and I differentiate that with respect to x, it will get an r times x to the r minus 1. The r factorial doesn't bother me, and it's a different problem how to shift it to r plus 2. I'm just looking at other bits in there. And of course, is that a problem? The answer is no, because once I write it as x to the r times r to the minus 1 over r factorial, once I put the value of, sorry, it's not the r there, it should be x, I beg your pardon. Once I put the value of x is equal to 2 that are required for this particular one, that'd be 2 to the minus 1, or just simply half, and I can just dump it anywhere I want. So that's not the issue. So where do I start with something like this? Okay. I must admit, when I was looking at this particular question, I did try it. I do often sometimes try the questions as if I'm a learner myself, although I do have the solution, of course, from in my book, just to see if I still got it, basically. And the first step actually got me. I couldn't see the very first step. It's actually quite difficult. You can congratulate yourself if you actually found it. I'm sure there might be other ways of doing this, but in my solution, this is my first step. I'm going to divide both sides of this relationship, okay, by x squared. Okay, why do I want to do something like that? That will somehow create that shift that I've got with the r plus 2 factorial. Look what's going to happen. There's my sigma. Still r is equal to 0 to infinity, and this will become x to the r minus 2 over r factorial. Of course, I don't want to be insulting your intelligence. X to the r over x squared will give you this quantity. So that's definitely correct. Okay, and what can I do with this now? Let's write a few terms just to see what happens now with this particular sigma. What kind of terms do I get from this? So I'm going to get, of course, x to the minus 2 over 0 factorial plus x to the minus 1, when I'm putting, of course, r is equal to 1 in there, over 1 factorial, and so on. So I'm going to write the first few. So let me just move out of the way. X to the 1. Let's put maybe a couple more. X squared, 4 factorial, x cubed over 5 factorial, and so on. So what am I getting so far? All right, let's go to the next line. I'm going to copy this again. E to the x over x squared is going to be equal to, I'm going to come out of this notation and just concentrate on this. 0 factorial is, of course, 1, so that's going to be a 1 over x squared. 1 factorial is, of course, 1, so that's going to be, again, 1 over x this time. X to the 0 is 1, 2 factorial is 2, so I'm going to get plus a half. Now, when I start looking now at r, x is equal to 1, 2, 3, and so on, plus dot, 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 I forgot to write it, okay, maybe I can actually go back to sigma with r is equal to 1 and just check what happens now with these terms, because the factorials have actually shifted. Look at what happens here. 1, 3, 2, 4, 3, 5. So if we write the rest now in sigma notation, it's going to be from r is equal to 1 to infinity forever, and it will have terms that look like x to the r, 1, 2, 3, 4, and so on, but the factorials are 2 more than the r, so it's going to be r plus 2 factorial. Okay, that's rather good, isn't it? Because, of course, if we look at what I'm trying to get, I've got the x to the r, which at any stage I can replace with a 2, x equals to 2, so I'll give me the 2 to the r plus 2 factorial is there, and of course the only thing that's missing in there is this r at the front. And of course I gave a clue. This is not too difficult to see for somebody who is actually experienced with this type of work. It will come from differentiating this particular equation term by term. So let's do this one. So let's put an extra line. If we differentiate this equation with respect to x, I'm going to get d by dx of e to the x over x squared. It's going to be a quotient rule in a minute. Let's put these three terms together in one operator. D by dx of 1 over x squared plus 1 over x plus a half. And of course, let's put the d by dx in front of the sigma. D by dx of sigma to infinity from r is equal to 1, etc. All right. Let's see what we get. On the left, a simple quotient rule. So this will produce denominator squared. So it's going to be an x to the 4. Start with the x squared on the top left, differentiate your top, e to the x, minus, leave your top alone, e to the x, differentiate your denominator, 2x. Let's put the 2, we can just about squeeze it, I guess, in there. Actually, let's make a little more room. 2x, e to the x. If we need to simplify that, we can. So for the time being, that's that. Equal. The differential of that is very easy. It's going to be minus 2 over x cubed, minus 1 over x squared. The half will disappear. And of course, this particular differentiation, I'm going to do it inside the sigma. So let me just do it up here. So I'm going to rub off the d by dx from there, and I'm going to move it inside the sigma. I'm interchanging summation and differentiation, d by dx of this. What will happen in there now? Of course, there's some bits which are independent of x. There's no x dependence. So of course we have that 1 over r plus 2 factorial. There's no x in there. The only thing that has the x is that. And of course it will differentiate to r x to the r minus 1. So at the moment, this is looking rather good, because if I put x is equal to 2 in there, okay, I'm almost getting what I need to get, but for an extra bit, which I will deal with it. So let's do that. When x is equal to 2, I'm going to have to do that to the entire equation. I'm going to get 4 e squared minus, oh, it actually cancels. Even if it didn't cancel, it doesn't really matter. That's not the issue. I will say something about it in a minute, just in case you just think, oh, that was very convenient, you're getting a 0 in there. It's got nothing to do with that. So I will say something about it in a minute. So that's minus a quarter, minus another quarter. And of course, this now almost constructs what I'm after. R is equal to 1, r times 2 to the r minus 1 over r plus 2 factorial. Absolutely beautiful, I think this question is. And to finish it off, this cancels completely, so that's a 0. And a quarter is a half on the left, positive half. And I'm going to just abbreviate the workings there. I can't be bothered to just go and write very low on the board. You see this 2 to the r minus 1. I can write it 2 to the r times 2 to the minus 1. And of course, 2 to the minus 1 is, of course, a times a half. And this a half, I can move to the front as a multiplicative quantity outside the operator. So that's actually equal to a half sigma from r is equal to 1. And of course, we have our answer now on the next line. And we managed to do this particular sum to infinity. Halves will cancel on both sides, and therefore this particular quantity is equal to exactly 1. Half divided by half is of course 1. And I want to say something about this little thing that happened in there. It just happened to be 0. What if it didn't cancel? Well, if it didn't cancel, it was just different quantities that we want. Let's say that was a 3 we were after, or something like that. What would have happened? We would have had in there, just out of interest, 9 e cubed minus 6 e cubed over, I don't know, what's 3 to the 4, 81. You can cancel some crap, and then some numbers that would have come across. So the answer would have been in terms of e. This particular one is very special because the e's just happen to cancel, so you get a nice, beautiful number of 1. But you could have summed it, for example, if that was a 3, using exactly the same method. The only difference, the answer will not be as beautiful as that. Okay, I hope you follow what I've just done in there, and you learned an awful lot of things with serious, my favorite topic. And I'll see you very soon. Who's laughing now?